Hey, future engineers and scientists, I've got a cool one for you today. Have you ever looked at some of the insane special effects in movies and thought, wow, I wonder how they did that? Well, today I'll show you that some of these awesome effects are actually using the same methods that engineers use to design boring old pipes and reactors. Hey, if you're new to the channel, welcome. My name is Hein and I've worked as a chemical engineer for more than 20 years. And I made this channel to help you decide if a career in engineering or science is right for you. First, what do I mean by special effects? Let's take a look at a few, and while we do, ask yourself, how was this done? Now, I hope it's obvious, but the film crew of Oppenheimer definitely didn't set off a real nuclear bomb. I'm sorry to disappoint you, but Dune wasn't actually filmed on Arrakis, and there aren't sandworms in any desert on Earth that I know of. Also, you didn't miss a special mission to the extrasolar moon of Pandora. Nope, all of these insanely good movies were made right here on Earth by some very hard-working and dedicated people. So, any ideas for how they did it? Well, there are tons of good videos diving deep into movie special effects, which are also called CGI or VFX. I've linked a few in the description below. Let's go back in time a bit to some of the earliest forms of this, known as matte painting. In this technique, filming would be done through a glass sheet. The interesting things, like people moving or some action, were happening in the clear part of the glass. But for large parts of the screen, the scene is actually static, meaning it doesn't change. So this part could be painted onto the glass to look like anything. Then it is placed in front of the camera and filmed through to bring everything together. In this way, you don't have to build an insanely expensive recreation of a place that doesn't exist, but instead just pay a really good artist. Imagine the time and skill involved. A variation on this approach is used in the recent movie Dune, as shown by the great channel The Corridor Crew. Go check it out. Link below. This scene uses a miniature, although it's still quite large and had to be placed on top of a stadium. The miniature of the spaceship is surrounded by hundreds of small soldiers, kind of like little toys, but it has a small hole in its floor. The people that move are actually far away from the miniature, and by filming through the hole, it looks like one complete scene with everything at the right size. Pretty amazing, right? Modern VFX artists use a massive range of techniques. For example, in Oppenheimer, the director Christopher Nolan wanted to use exclusively photographed elements for the special effects. So these included filming thermite explosions, moving particles in turbulent water, or employing cloud tanks to create the visuals that look like fire. They also used miniatures and long exposure photography. All of these pieces are then brought together to make it look like a nuclear explosion. A fantastic breakdown of this whole process with more detail is available on the channel The Movie Rabbit Hole. These days, with the use of computers, VFX artists can also animate on top of filmed characters, changing the way they look and adding extra elements to the scene. Here you can see this being done for the movie Avatar: The Way of Water. And yep, the actors actually have to hold their breath during filming, for which they had to undergo months of special training. But back to some more specific examples. Consider this scene from the Mandalorian series, also broken down by the corridor crew. So, the water and the spaceship are not real. They have been created by VFX artists. Do you think it's possible for someone to accurately draw or animate something like this? Could they replicate the motion of the splashes realistically, or draw every drop of water? Well, I suck at drawing, so definitely not me. But even if somebody was exceptionally skilled, drawing every single frame to replicate the flow of the water would take an insanely long time. How did they do it? Well, let's look at something a little bit different. Here are some examples of engineering designs showing fluid flows in different equipment. How do you think these were made? Here we have a liquid filling a container. Notice how all the little splashes and collisions with the walls are recreated. Even the little ripples and waves on the surface. And here we have the fluid motion inside a stirred reactor. See how the simulation can capture the detailed motion of the fluid as it's being pushed by the stirrer, or impeller as we call it. Chemical engineers use this approach to simulate how fluids behave inside, for example, pipes and reactors. This allows us to do some important calculations and find flaws in our designs. For example, we can calculate how big a pump needs to be to make a fluid go through very long lengths of pipe. Or, by looking at the reactor, we can find dead zones, or areas where the liquid is not moving and so the reactor won't work properly. We can also see if the stirrer is working properly to mix everything up. Any ideas how this is done? Well, the answer is fairly simple. Math. Lots and lots of math. This is something called computational fluid dynamics, or CFD for short. In CFD, we start with the fundamental equations of fluid motion, which I'll explain in another video. Then we define a mesh, which is just a 3D recreation of the thing that we're interested in, like a pipe or a reactor. Finally, we can solve these equations starting from some known point. For example, where all the fluid is lying still in the tank before we turn on the stirrer, or at steady state. Okay, great. So how is this actually used in special effects? Well, these days, those same simulations, although slightly modified, are built into some of the software used by VFX artists. It's actually quite easy. I'll show you a simple example in the free program Blender, using something called flip fluids. You can check out the full video at the link below. We begin by setting up a domain. This is a volume where the liquid is allowed to go. And then we add a fluid source where the liquid can pour out of. Next, we need to ensure the right interactions take place between the container and the fluid. In this case, by using an inverse obstacle. A force field is added to push the fluid and control its motion. It's fine-tuned with spin strength to generate the vortex effect. The simulation is enhanced with white water particles that look like foam, bubbles, and spray. After increasing the resolution, we adjust the gravity and speed at certain points in time to create a slow motion effect. Finally, we add lighting, materials, and environmental textures to achieve the final result. Okay, maybe not super easy, but still pretty cool, right? In this way, we can create more complex effects, like this huge wave scene from the movie Interstellar. Or this insane tsunami crashing into a city from VFX Grace. And yes, one of my favorite movies, Waterworld, did use some scientific simulation software, but it was the early days and nowhere near as spectacular as what we can do today. Well, there is a lot more to discover. If you found this interesting, subscribe to stay tuned and check out some of the other videos on the channel. We cover all sorts of cool stuff in science and engineering. I hope you enjoyed this dive into fluid simulations and learning how the same simulations used by engineers have found their way into the movies we love to watch. Cheers!